Here we have a spike in the memory paging rate, right? Well, is that normal or is that an aberration? Well, we can see that it's happening at a particular point in time, but the ability to go look at this historically, from my perspective, is pretty critical.
Mm-hmm.
Why don't we talk about weight type analysis for a minute? You want to take a whack at this one?
Yeah, absolutely. So weight statistics are important to most all relational databases. Oracle has them, Postgres has them, SQL Server has them. And although the specific names for each of the weight categories vary, they basically tell us how long a process is weighted to complete and in what was the general cause. So you might see, for example, in SQL Server, it tells you that you have had processes wait due to locking for a read transaction, or processes locking for insert operations. It could be something like you're waiting on network I/O. So it really helps you to understand, in this case, the number one there is memory and CPU. So you could see by looking at the weight statistics, am I working on a solution that's in the right ballpark? So that old example that we've used of throwing more cores into the box, if you don't have a CPU or memory related issue, that's not going to help at all. So it really helps you make sure that you're working on the right problem.
Yeah, that's right. And the example I use is, let's say we're just selecting 100,000 rows from a table, right? You got some amount of time spent getting the data off the disk into memory. You've got some amount of time identifying that we've got the right rows, and some amount of time shipping the data back to the client. Well, so you've got some network time, you've got some I/O time, you've got a little memory time, plus you've got the processing time. And if all the time is being spent at the network level, you can tune that query forever. The only way to fix it is to reduce the number of rows in play. If you're spending all your time in I/O, well, guess what? You can tune the query forever, but unless you have a faster I/O device or more memory so that it gets cached faster, you're kind of out of luck. So I think you've hit that nail right on the head. So trending becomes important. We've talked about these concepts, and we are running a little low on time, so I'm going to move forward a little bit faster. Let's talk about network just for a moment, because one of the things that happens with a high degree of frequency, in my opinion, and high is some measurable percentage of the time. I'm not saying this is 80, but 10% of the time, the network people are going back and forth with the database people, and the database people are saying the network's slow, and the network people are saying, my tools are showing that this is flying like a son of a gun.
Yeah.
One of the things that SolarWinds does is ping the DBMS. So from the SolarWinds tool, you have effectively a SQL client open, and it does a select one, which is going to happen instantly because that's all. There's nothing there to do, and it goes out to the database, comes back with the one, and guess what? Now you're measuring how much time it took to get back. Now, in most environments, what I've found is that this will come back if you've got DPA running in the same physical room as your database server. These are pretty much zero uniformly. I mean, it just rounds down and there's no elapsed time. If you're running on some sort of virtual machine, regardless of the vendor, it's typically about 1 millisecond all the way across, just for the ping time. And again, these are rounding things, right? And if it's above that or you're getting spikes, there's something you may need to explain. Your experience is similar?
Yes. The only time I've seen it vary is on the 1% of the highest performance OLTP situations. So in one case, we worked with a customer that had a workload that included tens of thousands of concurrent users, hundreds of cores on the box, and things were slowing down due to network, but it was mysterious. We had difficulty troubleshooting that and getting to a root cause. And what we eventually came to learn was that what was happening was there wasn't enough OS CPUs available they were all working on SQL Server, so the OS CPUs were not available to process the working networking load. And so we used a setting called CPU affinity, which really very few cases you ever need to use this. But what it did is we set aside 2 CPUs just for networking. So we could manage all that. And when that happened, the NIC was able to handle the workload and things got much better. But
Yeah,
generally, you know, that's an edge case.
it's an edge case, but guess what? If you don't have a tool that's showing you that it's network performance on the database side, do you even think to look at
Right.
that? I mean, it's a much harder thing to track down without this. And I'll mention one more thing. Because this is a ping of the DBMS, if the CPUs are running at 100%, this can be off by a little bit. But one of the things that we find with
Right.
SQL servers, SQL Server tends to run fine if the CPUs are at 98 or 99%. But when you hit 100,
Mm-hmm.
suddenly there's a wall.
Very true.
Yeah, this is a great discussion tool. Again, always look at the scale. If we're spiking up to 2, 3, 4, probably not a huge deal. I was at a client once where this is all in the 300 range. And the
Ooh.
client said to me, you know what, Jeff, I've been trying to explain to network for months that things are slow and they keep telling me no. I now have quantitative proof, which was really nice.
That'll end finger pointing very quickly.
Yeah, as soon as you can show somebody a graph saying the SQL server is not getting what it needs or it's taking too long, it's much more important. And you know, when you get into, I mean, a lot of our attendees here are healthcare related, and when the doctors are calling in
Mm,
complaining, I can't get my uh, I can't get my patient records up. I can't. The cardiac
mm,
machines are running slow, and everything's running on SQL Server these days, right? Becomes
mm-hmm.
really important to know that you're solving the underlying problem. Let's talk about CPU a little bit. I love this particular view of this particular set of resources, and I'm going to go first because it tickles me, and then you can add to it whatever you like. What we're looking at here is first instant CPU versus OS CPU, that top right versus the bottom left. And if this were my product, I would probably change it so that I've got instance above OS simply
Mm,
because I like to compare those two because those should be shaped the same. If they're not,
right.
right, if they're not, it means something is running on the computer or on the instance on the virtual machine that is not SQL Server, which is not a recommended practice. And it hasn't happened in the last
Absolutely.
few years, but in the olden days, I used to get that a lot, that somebody would say, only SQL Server is running on the box. And I would point and say, what's this?
Yes. We even had a customer who they had outsourced their administration, and suddenly things were not finishing in the preventative maintenance window every night. We looked. They the admins did not realize that SQL Century or DPA was on that box. And it turns out that the admins were running a Bitcoin miner thinking that nothing's happening at night. So, yeah, so they were trying to make money on that.
That's interesting. I've been at, I don't know if I should say this on a recording, but I will. I've had two separate clients that found their admins running porn sites from when they're within their financial or healthcare applications uh, without anybody knowing until a tool that was monitoring picked up on that. But
Wow.
once was an aberration, two was, oh my God, I can't believe this is happening.
Right, indeed.
One other thing I really like about this one is the signal weights percentage. And the signal weights is an indicator that we've requested a CPU and can't get one. And what does that really mean? Well, we can see that the instant CPU is low. Why would the signal weights be high? You want to take a whack at that one, or would you like me to?
Go ahead. Since we're running a little short on time, let's run through that.
Sure. The idea behind the signal weights is that if you're running a process in parallel, if the SQL Server says, I want 8 cores, 8 threads to run, then it will wait until 8 threads become available. So if you're running any process which is hogging a thread, or threads aren't available, or particularly within VMware environments, you can't get all the threads you're looking for, then you're going to get a wait. So this is an indicator to us to drop your max stop. But we found a really cool one, about 2-3 months ago, where we dropped the max stop down to 1, which is, hey, you can only get 1 anyway. We're still experiencing signal weights percentage, and we were able to use that as a smoking gun to figure out that the virtual machine had not been configured
Mm,
properly, and it was not able to get
right.
to the CPUs that wanted.
Hmm.
So again, running low on time, I'm going to speed through this a little bit. So as we talk about queries, um, it's important to get the slow running queries that the users are complaining about. That's a good place to start if you're doing a tuning exercise and if you can identify them. But the other thing we like to do is identify heavy hitters. How do you identify a heavy hitter? Well, a good tool, SolarWinds DPA is a good tool, identifies all of that user experience time that we talked about and adds it up. So we can say that a particular tool here between 3 and 4 p.m. was using a large amount of time. And what I like to do is just start from the top and tune the first 5 or so. And then once those are
Right.
tuned, get started with the next ones. Here,
Hmm.
as we're looking at this graph, the write log time, that is that VLF issue we talked about.